Hello everyone, my name is Saifuddin Hosni Abdelghani Abbas. My student ID is 0348566. Module name is Mathematics 2 and the semester intake which was March and the year 2021. So today I will be discussing the ordinary differential equation, or as we call it ODE, and how it is used and implemented in the healthcare industry. Before discussing the implementation, firstly, we must discuss the meaning of the ODE. In terms of mathematics, we say that differential equation is the relationship that involves the derivative of a function or dependent variable with respect to the independent variable. An ODE is an equation that involves some ordinary derivatives of function and function. Often our goal is to solve ODE to determine what a function or functions that satisfy the equation. The functions are the one which denotes some sort of operation performed, and rate of change during the performance is the derivative of that operation, and the relation between them is the differential equation. These equations are represented in the form of order of the degree, such as the first order, second order, and more. Its applications are common to find in the field of engineering, physics, and healthcare. Now, regarding the application in healthcare, it is used in medicines where pharmacokinetics, I don't know how to say it, but it is the study of how drugs are processed within the body. So, pharmacokinetics can be broken down into 5 general steps. So, the first thing would be liberation. Liberation, which is the drug is released from its pharmaceutical formula. The next would be absorption, which is the drug enters through blood circulation, and then distribution. The drug is dispersed through the body. Fourth, metabolism. The drug is processed and broken down by the body. And then exertion, and it's where the drug leaves the body. So, in order for doctors to prescribe the correct dosage of a drug and provide the correct amount of drug that he should abuse, so there would be no overdose or underdose. Actually, doctors use calculus to find out, or math to find out the dose for each person. In applications of differential equations, the functions represent physical quantities and derivatives, as we know, represent the rates of change of these qualities. Therefore, a differential equation describes the relationship between these physical quantities and their rates of change. In order to create a differential equation that describes the physical quantities of a drug in relation to the rate of change, let's consider the following variables. So first of all, the drug dosage in milligrams, then the concentration of drug at any time, and third, time in hours since consumption of drug. In addition, there will be, so the above variables were clear, anybody could guess them, but these are a little bit more complicated. They have something called Ka, which is the absorption constant of a drug, and then Ke, the elimination constant of a drug, and V, which is volume of drug in a body, and the bioavailability. Bioavailability is the amount of drug which has already been absorbed divided by the total amount of drug available. Thank you. This was my First assignment.